Now let's take a look at part A. So it says Coach Dunn needs a first, second, and third receiver from the 15 tryouts at the beginning of the year. How many ways can he do this? So here I'm going to say yes, we do need an arrangement here. The reason here is because take a look at these three different possibilities. Having Ricky be first, Joe being second, and Lee being third is different from Lee being first, Joe being second, and Ricky being third. For example, let's say that Ricky is the best player, so you want him to be first. But let's say in the game he gets injured, so now they put Lee to start first, which can affect the momentum of the game. So here the order does matter. Even though it's the three same people, the arrangement plays critical to the outcome of the game. Let's take a look at part B now. So it says Coach Dunn wants to choose 4 players from the varsity team of 30 to represent the team for the coin flip. How many ways can he do this? So does this require an arrangement? Yes or no? And I'm going to go with no, because here it doesn't matter which 4 players he picks. He only wants 4 of them to be present at the coin flip. So it doesn't matter if they're standing the way in which they are standing, whether they're standing like this or if they're rearranged and standing like this. The order doesn't matter because it's not going to affect the outcome of the coin flip. So here we don't care. So now for the last one, the local pizza shop offers pizzas with any combination of up to 10 different toppings. How many different ways may pizzas be ordered if you can choose any of the 3 toppings? And here there is no arrangement needed because you don't care in what order the toppings are placed. You just care about eating your pizza with your desired 3 toppings. So it doesn't matter if they put the pepperoni first and the sausage second. That doesn't matter to you. You just want to enjoy your food. Okay, so now let's use this common sense and let's use our best judgment in order to decide how to set up certain problems when we put a context into them. Example 4 is the following a permutation or a combination, and then we have to write an expression to represent the situation and finally calculate the given value. So here it says, how many ways are there to give 3 honorable mention awards to a group of 8 contest entrants? So here, let's say you're the host and they tell you that you need to give out 3 shout outs to for example, to Alex, Kimberly, and Jay. So they tell you to give a shout out to each one of these students or people, but again, you're not given an order in which to do so. You're just told that you have to mention them in your speech. So here, the order doesn't matter whether you say Alex, Kimberly, or Jay, or Jay, Kimberly, and Alex. You basically said the 3 mentions that you were told to. So here we have a combination because the order does not matter. So out of a group of 8, we need to choose 3. So we're done with part 1. This is a combination. We're done with part 2. We wrote an expression. Now we have to calculate the value here. So 8 choose 3 is the same thing as 8 factorial over 3 factorial times 8 minus 3 factorial. And then that equals 8 factorial all over 3 factorial, 5 factorial. I'm going to expand the 8 all the way down to 5 factorial. So 8 times 7 times 6 times 5 factorial all over 3 factorial, 5 factorial. So 5 factorials are going to cancel out. So I get a total of, 8 times 7 times 6 is 336. And then 3 factorial is the same thing as 3 times 2 times 1. So we get 336 all over 3 times 2 is 6, 6 times 1 is 6. So 336 all over 6, we get a total of 56 possible combinations or possible shout outs that we can do. So again, there's 56 possible combinations in which we can give 3 honorable mentions from a group of 8 people. So out of a group of 8 people, we have to choose 3. Let's do one more. So here we have example 5. How many ways are there to award first prize, second prize, and third prize to a group of 8 contestant entrants? Now notice here that they give us a first, second, and third. So let's try to make sense of this by drawing some placeholders here. So here is first, second, and third. So now I hope you realize that here the order does matter, because once we choose someone for first place, then that person cannot win second place. So now there's 7 people able to choose, able to get the second prize. Or better yet, take a look at this example. Here you can clearly see that these 2 rearrangements are actually different, even though it's the 3 same people. So for example, Kimberly being in first place is completely different from Kimberly being in third place. Here she might feel like a winner, but in this situation she may feel devastated, almost maybe want to cry for not getting first place. So here, even though we have the 3 same people, the rearrangement is different, so the order does matter. So order matters here. And because order matters, we're going to have to compute a permutation. So out of 8 people, we're going to have to do P3. So here we have 8 factorial over 8 minus 3 factorial. And then we get 8 factorial over 5 factorial, which we expand 8 times 7 times 6 times 5 factorial. And here we get 8 times 7 times 6, which I believe is 336. So we have 336 ways in which we can choose first, second, and third prizes from a group of 8 contestants. So go ahead, finish the rest of the assignment, and I'll see you next time.